Good morning, good afternoon, and good evening, everyone. Welcome to today's webinar entitled Modeling Trade and Tariff Volatility, a Practical Approach for Cost Engineers. My name is Jeff Miller, and I'm the president of the Society of Product Cost Engineering Analytics, or SPCEA. On behalf of SPCEA, I'd like to thank you all for joining us. I'd also like to thank 3C Software for sponsoring this webinar and for supporting the cost engineering profession. In today's world, trade policies and tariffs are changing rapidly. They're creating new challenges for cost engineers who are tasked with managing global sourcing, pricing, and profitability. Companies must now respond quickly to shifting market conditions while protecting margins and reducing risk. So in today's session, we'll be discussing practical ways to incorporate trade and tariff volatility into cost models and sourcing strategies to support better business decisions in an increasingly unpredictable global market. It is now my pleasure to introduce Mr. Sam Smith from 3C Software. Sam is an expert in manufacturing analytics and profitability improvement, and he has extensive experience helping manufacturers navigate complex sourcing and cost challenges. Please join me in welcoming Sam Smith.
Awesome. Thank you, Jeff. I hope I can live up to some of those highlights that you just shared with everybody. I'm going to go ahead and share my screen so we can dive into the presentation we're all here for today. Can you quickly or someone quickly confirm for me that it's sharing correctly and everybody can see it?
Yeah, it is sharing. Yes.
Great. Awesome. Well, I'd like to reiterate what Jeff had said a moment ago, everyone. Good afternoon, morning, evening. I know we have folks joining us from all over the world, so wherever you're joining us from, I greatly appreciate you spending your time with me here today. As he mentioned, we're all here to talk about trade and tariff volatility, specifically what that means for us as cost engineers and what we can actually do about it in our models. So before we get into it, a quick note on the format. I've got about 35 or so minutes of material, and we'll save the last 5 to 10 minutes for questions. So if you could hold those till the end, or even better, drop them in the chat along the way, we'll make sure to pick those up at the end. So with that said, let's get into it. So quick context of who I am before we get into the material. So I work for a company called 3C Software, where we've been building and refining enterprise cost and profitability models for going on 36 years now. And what I think is genuinely unique and distinctive about 3C Software is that everyone in the business, regardless of their role or function, thinks like a cost engineer. That includes me in sales. When I'm working with a customer, I'm thinking about their cost structure first and the software problem second. And we certainly also have our own platform called Impact ECS, which companies use across a wide range of industries for its analytical capabilities, including modeling, profitability analysis, variance analysis, scenario simulation. Now, the last one is really what brings us here today, simulation around sourcing, trade, and tariff. So let's dive into it. Let's start with an honest picture of where most organizations are now today. Most cost models were built for a stable world. Standard costs were set once a year. Tariff rates were treated as fixed inputs. Sourcing assumptions are baked in and rarely revisited. And that approach worked well enough when the environment didn't change faster than our model update cycle. The issue is that's no longer the world that we're operating in. In the last few years, we've seen tariff schedules shift within weeks or sometimes even days' notice. Trade lanes that were once reliable are now variables. Suppliers that made sense last year might not make sense today, and that's not because their prices changed, but the cost of doing business with them has changed. And here's the problem that creates for us specifically as cost engineers. When trade conditions shift faster than our models update, the analysis we're providing stops reflecting reality. We're answering questions with numbers that are already stale and out of date. The organizations navigating this the best aren't the ones with the best forecast. They're the ones whose cost models were designed to answer what if questions quickly before decisions got made without them. So let's talk about how we build models that can actually keep up. The first shift we need to make is treating trade cost as a modeled input rather than an adjustment that we make after the fact. Most of us have been in a situation where a tariff changes and the response is to go find the affected line items and manually update them. That works once, maybe twice, but it doesn't work when conditions are constantly changing, and it definitely doesn't work when someone needs answers within a 24 hours notice. A trade-aware cost model is designed differently from the ground up. There are 4 dimensions that we need to think about when designing it. The first is country of origin. Where a component is sourced determines which trade costs apply. The same part from 2 different regions can carry materially different landed cost, and the difference needs to be calculated by the model, not live in a spreadsheet off to the side. And it's worth noting that a single supplier might even have multiple ship from locations, so our models may need to go beyond the supplier level entirely and calculate cost from the ship from location itself. Now, the second is the destination market. Where a product is sold affects duties, import costs, and compliance requirements. Our cost structures should reflect where revenue is actually realized, not just where things are being made. And for those of us working in multinational organizations, the destination matters for the sourcing of raw materials too, not just the sale of finished goods. The same component sourced from the same supplier location can carry materially different costs depending on where it's delivered, and that asymmetry has to be in the model. Now, the third is the trade lane. The path a product takes from source to sale creates its own cost layer. When we model by trade lane, we surface exposure that's blended assumptions tend to hide. We should also note that the shipping method affects more than just the freight line item itself. Insurance rates, packaging requirements, inventory carrying cost, customs and duty and processing fees all shift depending on whether something moves by air, sea, or ground. And a model that only captures the freight rate is leaving other real cost elements on the table. Now, the fourth and final is the bill of materials itself. For manufacturers, tariff exposure primarily lives at the component level, and a trade-aware BOM should be able to link each input to its supplier options and the cost implications that follow. Now, these 4 dimensions are where trade costs enter the model. Let's look at where they show up in the cost structure itself. So trade costs don't hit a single line item. That's one of the things that makes them tricky to model and easy to underestimate. There are 3 practical places in the cost structure where they tend to mostly show up. The first is material cost. This is the most obvious and visible one. When a tariff changes, the price we pay for the component changes, but it's not always a straight pass through from the supplier. Sometimes the supplier can absorb part of it, sometimes they pass it all through, sometimes there's lag. Our models need to be able to reflect that variability, not just the current rate. The second is the landed cost. This is where duties, tariffs, freight, and other costs stack on top of the material. It's also where a lot of organizations have a blind spot because landed cost tends to live outside of the core cost model in a separate calculation or estimate. When that's the case, any scenario analysis we run on the material side is incomplete. The full picture requires landed cost to be calculated by the model, not just a single plugged value. The third is intercompany flows. This one is the most relevant for multinational organizations. When products move between entities within the same company, trade structures affect transfer pricing and how margin can get allocated across the businesses. A tariff change in one region can ripple through the intercompany cost structure in ways that aren't obvious until you model them explicitly. Now, the common thread across all 3 of these is that trade costs are structural, not incidental. They need to be designed for into the model, not layered on after the fact. Now, I want to take a step back here and talk about how we frame our role as cost engineers in a volatile trade environment. There's a mental model I find useful, and it maps pretty cleanly into the 3 circles that you see here on this slide. The innermost circle is what's fully within our control. Raw material suppliers we've selected, make versus buy decisions, BOM design. These are levers that we own. When trade conditions shift, this is where we should look first on ways to respond. The middle circle is what we can influence but not fully control. Freight and logistics, point of origin, transportation mode, manufacturing location. We may have input into these decisions, but they're often shared across divisions within our own organization or even across organizational boundaries. Your supplier might have just as much say over shipping method or ship from location as you do. Our job here is to make sure that the cost implications of each of these options is visible to everybody who has a hand in making those calls. Now, the outermost circle is what we can't control at all and can only model. Trade policy, geopolitical events, fuel cost, these aren't levers, they're variables. And the right response to variables isn't to try to manage them, it's to make sure our models can reflect them accurately when they change. And that distinction is the point. We shouldn't be spending energy trying to manage things in the outer circle. We should be modeling them and preemptively at that. So when tariff policy does shift or fuel costs do spike, we already know what it means for our cost structure, and we already have scenarios that are ready to share. The goal isn't to predict exactly what's going to happen, but it's to be never caught flat-footed when it does. But we also have to be thoughtful about where we invest our modeling effort. Not every variable in the outer circle deserves the same level of precision or time, right? Tariff rates and fuel cost are high likelihood and high impact variables because they move regularly and the cost implications are material. Those are probably worth building out very carefully and spending a lot of time and energy in understanding the exact implications. Other geopolitical variables might be a real risk, but the effort required to model them with any accuracy may not be justified just based off of how they actually affect a decision. Part of our job as cost engineers is making that call, knowing which variables belong as live inputs in the model and which ones are better left as assumptions that we revisit periodically. Now, everything that we've talked about so far sets up a fundamental question about how we design our models. Most cost models are static by nature. They're built to capture a point in time, current rates, current suppliers, current trade lanes, and that's not a flaw. It's largely a reflection on the tools and processes that most of us have inherited. But a static model has a shelf life, and in the current environment, that shelf life gets shorter by the day. A dynamic model is designed around a different question. Instead of asking, what does this product cost today? It's built to answer, what does this product cost under a specific set of conditions? And that shift in design philosophy changes everything about how we structure inputs. Now, this slide shows 3 examples of the kinds of questions a dynamic model should be able to answer quickly and reliably. What happens to total product cost if tariffs on a component increase 15%? What does our cost structure look like if we shift sourcing from one region to another? Which products carry the most tariff exposure if trade conditions change next quarter? Now, these aren't exotic questions. Most of us have probably been asked a version of them at some point in our careers. And the difference between a team that can answer them in a day versus a team that needs weeks isn't analytical capability, it's the model design. A dynamic model is a design problem that starts with building variability in from the beginning and not retrofitting it after the fact. Now, this is one of the more important slides that we're going to cover today, so I'm going to pause for a moment and give it a second to breathe. So when a tariff changes, the instinct is to go find the affected component or components and update the rate. Done. Model updated. But that's not actually what happens in the full cost structure. Let's walk through it together, right? A tariff increases on a component sourced from a specific region. That's the triggering event. But what follows from that single change? Material cost goes up. That's obvious, but landed cost recalculates too, because duties are applied on top of the component value. Overhead absorption shifts if the higher material cost changes the basis on which overhead is allocated. If that component feeds into a subassembly, the subassembly cost changes. If that subassembly is shared across multiple finished goods, each one of those now needs to be recalculated, otherwise they're misrepresented in the model. And that's before we even get to the profitability layer, or we get to try to doing variance analysis. If our standard costs are stale, our variance analysis is telling us the wrong story. If we're using those costs for transfer pricing across entities, we might have a compliance exposure issue that we haven't accounted for either. One line item changed, a cascade of downstream effects follow. The point isn't that it's impossible to manage. The point is that it has to be managed at the model level, not the line item level. A model that's designed with these dependencies built in will propagate a tariff change correctly and automatically. One that isn't will require someone to manually chase every downstream effect and hope that they didn't miss any along the way. Now, there's a pattern that shows up in a lot of organizations. Cost engineering gets pulled in after a sourcing decision has already been made, or after a product design is already largely locked in. The ask is to validate a number that's more or less already been committed to. And that's a difficult position for us to be in. And in a volatile trade environment, it can be a real expensive position for the business. The earlier we're involved in a decision, the more levers that are still available. At the component selection stage, we can help evaluate supplier options across regions with full trade cost visibility before anyone has committed to a source. At the product design stage, we can flag BOM configurations that carry a concentration of tariff exposure before they get designed in. At the at the stage of selecting a manufacturing location, we can model the full cost difference between producing in one region versus another, including trade costs before capital ever gets allocated. Once those decisions are made, our options narrow significantly. We're no longer evaluating alternatives, but managing the consequences. The shift we're describing here isn't just a process change, it's a positioning change. It requires us as cost engineers to have a seat at the table earlier, which means having the analytical capability to answer questions quickly enough to be useful when decisions are still in motion. In a stable environment, being involved late is inconvenient. In an environment where trade costs can swing materially with little notice, it's a real business risk. Now, the last slide is about when we get involved in the process, and this one's about who we're working with when we do. Sourcing, manufacturing location, product design decisions, none of these are made by cost engineering alone. They're cross-functional by nature. And that creates a specific challenge for us. Our analysis is only as useful as the degree to which people making decisions can act on it. That means not just building models for ourselves, we're building models that need to communicate clearly to finance, to procurement, to supply chain, to product engineering, and sometimes even senior leadership who might not have a finance or costing background at all. Each one of those audiences is asking a slightly different question. Finance might want to know what the margin impact is. Procurement wants to know which supplier alternatives are viable. Supply chain wants to know lead time and logistics implications. Engineering wants to know if a design change actually solves a problem or simply moves it. And leadership wants to know the bottom line exposure and what their options are. Now, a good cost model in a volatile trade context isn't just analytically sound, it has to be legible across all of those different conversations. That means thinking about how we present scenarios, how we summarize exposure, and how we frame trade-offs in terms that land with each audience. Our job isn't simply just to build the model, it's to make sure the model drives the right conversation at the right level. Now, everything that we've covered so far has been about how we build and use trade-aware cost models at the product and component level. This slide steps back and zooms out to the portfolio level. The question here is, across our full product portfolio, where are we most exposed if trade conditions shift? Most organizations can't answer that question quickly, not because the data doesn't exist, but because it's scattered. Cost data may be in one system, trade lane information might be offline in an Excel spreadsheet or in another one, profitability metrics are in a different place. Pulling it all together in a coherent picture at the portfolio level is often a manual exercise that takes days and is already stale by the time it's even done. What we're describing here is essentially a stress test. Take your product portfolio, apply a trade scenario, a tariff increase on components from a specific region, say, a disruption to a major trade lane, or maybe a shift in freight cost. Then rank your products by exposure. Which ones are the most affected? Which ones flip-flop from profitable to unprofitable under the scenario? Where's the concentration of risk? That kind of analysis does two things. First, it tells you where to focus your modeling and mitigation efforts. Not every product needs the same level of attention. Second, it gives leadership a clear picture of the business risk in terms they can act on. Not cost variances, but margin impact across the portfolio. Organizations that do this well treat it as a standing capability and not a one-time exercise. Trade conditions are now dynamic enough that portfolio level stress testing probably deserves a regular cadence. Now, before we move into an example cost model that we've prepared for today, I want to land on three principles that tie everything we've covered together. And these aren't conclusions so much as starting points. They're things that we can take back and apply regardless of what tools or systems we're working with. The first is design for variability from the start. Cost models that hold up in a volatile trade environment aren't the ones that get updated the fastest. They're the ones that were built to absorb change without breaking. That means parameterizing trade inputs, building in sourcing alternatives, and treating landed cost as a calculated value rather than just a plug. The second is model the full cost chain, not just the trigger. When trade conditions change, the impact doesn't stop at the line that got updated. It moves through the entire cost structure, overheads, sub-assemblies, finished goods, margin. A model that only captures the trigger is giving us an incomplete picture, and an incomplete picture leads to decisions that will need to be revisited later on. The third is make the analysis legible beyond cost engineering. The value of a well-built trade model isn't just in the accuracy of the numbers. It's in the degree to which those numbers can drive a decision. That requires us to think about how we communicate scenarios, how we frame exposure, and how we translate cost impacts in business terms for audiences that need to act on them. Now, these three principles are the through line for everything that we've covered today, and they're also the lens through which we built the example that you're about to see. So I want to pause here before we get into the example, though, and acknowledge something that's been running underneath everything that we've talked about so far today. And that is the role of cost engineering is changing, and I think it's changing in a pretty meaningful way. Now, the traditional view of a cost engineer is reactive and transactional. Someone makes a decision, we cost it out. A design gets released, we validate the numbers. A supplier changes their price, we update a line item. The work's important, but it's downstream of the decisions that matter. What we've been describing today is something different. Cost engineers who are involved earlier in the process, who are modeling scenarios before decisions get made, who are translating complex cost structures into clear business terms for cross-functional audiences, who are running portfolio level stress tests that land on the CFO's desk. That's no longer a support function, it's a strategic role. Now, the organizations that are navigating trade volatility well right now tend to have cost engineering teams that have started to make this shift at least partially. They're not waiting to be asked, they're bringing analysis to the table proactively in terms that drive decisions rather than document them. That shift doesn't happen overnight. It requires investment in model design, in data accessibility, and frankly, in how cost engineering positions itself internally. But the environment we're in right now is creating a real opening for it. Trade volatility is a business problem that cost engineering is uniquely equipped to help solve. And the question is whether we're up to do it. So that's the context for what we're about to take a look at. Let's dive into a real example. So what you're seeing here is what you're seeing here is a tariff scenario form inside of Impact ECS. I've gone ahead and entered some data in to run a sample of scenario. I've named this scenario Q2 2026 stress test. And I want to draw your attention to a few things before we run it and see what happens, because this screen is a good illustration of what we've been talking about. First, the tariff rates are inputs, not assumptions baked into standard cost, right? Not a manual adjustment someone makes after the fact either. They live here by country of origin, and the model responds to them. You can see the example rates I've plugged in for Canada and Mexico are both 25%, China's 145%, Vietnam is at 46%, Taiwan at 32%, and Brazil at 10%. If we change a rate, the model recalculates. Second, notice the load rates button. In a production environment, these rates can be pulled automatically from a subscribed data provider or source file, which means that we don't have to keep manually updating these tariffs on our own, right? For today, we've preloaded them, but I've seen several people subscribe to data providers like Dun & Bradstreet that helps them keep up with what the input should actually be into their model. Third, and this is the part that connects everything, when we hit run scenario, the model isn't just simply applying a rate to a line item, it's traversing every BOM, identifying every affected raw material regardless of where it sits in the component hierarchy, and calculating a full landed cost for every sourcing option and servicing which supplier represents the best cost position under these new conditions. So with that set up, let's take a look at what it actually returns. So this is the raw material impact view. Every row is the supplier option for a given raw material, and the conditional formatting is doing some work here to help us read it. Now, for the video recording that you're seeing on my screen, I've simplified the noise a little bit by collapsing it down to a singular raw material, which has 4 different supplier options. And what you're seeing is that the red row represents the most expensive sourcing option for that material under this scenario. The green is the opposite, it's the least expensive. And that's not just current cost, it's simulated, fully loaded and landed cost after tariffs have been applied. So at a glance, we can see which supplier relationships still make sense and which ones the tariff environment has repriced out of position. And look at what's in the landed cost calculation columns. Base price, customs and duty fees, freight and insurance, handling and receiving, carrying cost, off-quality and shrinkage. Landed cost is fully calculated here, not plugged. Every one of those components responds to the sourcing decision and the trade lane it implies. This is important because the supplier with simply the highest base cost and tariff might still be a better option when you consider additional cost buckets like these. Additionally, organizations might not necessarily want to select the cheapest supplier. They might strategically select a different supplier, or even better, spread their sourcing across multiple suppliers to diversify their risk. Now, the goods classification code is also on this view, which matters because tariff rates are applied at the classification level. In the US, we call this the HTS codes, or Harmonized Tariff Schedule codes, but most major trading countries use a very similar harmonized structure. If a design change shifts the component's classification, we can see those cost impacts immediately. Now, this view answers one specific question. For each raw material we buy, who is the right supplier to be buying it from given today's tariff environment? That's the lever we control, supplier selection. Now, next, we zoom out from the raw material level to the finished good level. What we're looking at here is every finished good in the model with every raw material that's been identified as affected by the tariff scenario mapped underneath it. Once again, to keep the screen simple for this demonstration, I've collapsed some of the rows down, and what we're seeing is 2 identified raw materials that belong to the same finished good. Now, this isn't limited just to direct inputs either. Impact ECS has traversed the full BOM hierarchy, so raw materials that feed into a sub-assembly, let's say 3 levels down, still show up against the finished good that ultimately it becomes a part of. And now what we're doing is we're marrying the previous raw material data to the production and supplier plan. What you're seeing in the sourced volume column is the planned purchase quantity for each supplier needed to support the forecasted production volume of each finished good. The production plan and supplier plans are used here in this example are just the current versions in this cost model, but they could easily be updated to turn into more scenario inputs if we wanted to add complexity. Now, the extension by volume is really what changes the conversation. The red highlighting here isn't just marking the highest unit cost anymore, it's marking the greatest total cost impact. A supplier might look manageable on a per unit basis, but when you multiply that exposure by the planned purchase volume, the picture can change significantly. Limiting our analysis to unit cost alone can cause us to miss exactly that kind of concentration of risk. Now, the columns that really matter here for decision making are the current total cost, simulated total cost, and total cost impact or difference. That's where the analysis stops being a unit cost conversation and starts becoming a business exposure conversation. So let's look at what this data can do when we summarize it for another audience to consume. Now, while myself and us on this call as cost engineers might prefer to view data in the tabular format or a grid view, right? A dashboard can really help pull together our analysis in a view that's easily digestible for other stakeholders and audiences like we discussed previously. So I'm going to zoom in quickly so we can read this a little bit better. What you can see here is on the left-hand side in that highlighted orange tile, the dashboard is pulling the same scenario that we just ran, 2026 Q2 stress test. You can see across the top, we've highlighted some important numbers that are worth calling out. Raw material cost goes from about 30 million to about 34 million, which is just over a $4 million impact or just over 13.5% across the entire raw material base. 8 finished goods have been identified as affected because they have a raw material that they consume that has been affected by the tariff conditions that we've set. And interestingly enough, Canada is the highest impacted country despite not having the highest tariff rate. Now, the country breakdown on the left-hand side continues to tell us that story about the tariff rates and how they affect our raw material cost base. Both Canada and China are driving roughly 85% of the total impact, despite China carrying the much higher tariff rate. That's a volume story. We're sourcing more from Canada, so even the 25%, excuse me, so even at 25%, the absolute impact is comparable to China at 145%. Now, the charts on the right show cost impact by finished good and raw material. Current versus simulated are sitting side by side, current in gray, simulated in orange. This is the portfolio stress test view that we described earlier. At a glance, a leadership team can see which products are carrying the most exposure and where the concentration of risk lives. At the finished good level, you can see clearly that 3 of the 8 finished goods jump out at the top as carrying most of the risk under this given scenario. When we look at raw materials, we can see almost all the risk concentration in a single raw material, and maybe that second one is worth drilling into as well, with everything else underneath it looking fairly immaterial on the chart. This is what it looks like when trade cost modeling is built into the infrastructure rather than just bolted on after the fact. The analysis that used to take days to assemble is here in moments when we hit that run scenario button. Now, I want to close this example with an important point, and that is simulation should be an iterative cycle and not a one-time exercise. If this were my company and I was running this simulation for real, my next step would be to start modifying supplier volumes, seeing if I could isolate the China exposure by shifting sourcing towards lower tariff countries, and then run it again. Since Canada is carrying about half of the impact, I'd also want to play with the supplier base costs coming from Canada. Maybe shifting volume from Chinese to Canadian suppliers could help us negotiate better pricing, reducing the Canadian impact as well. That's now a third iteration of the story. I want to continue to build several versions of this scenario and be ready to tell a story rather than simply reporting the numbers. That's the difference between analysis that informs a decision versus analysis that can drive one. Now, everything we've walked through in the demo is a practical illustration of what we've been describing throughout the session. But I want to take a moment and talk about what makes this kind of analysis possible from an infrastructure standpoint, because the model doesn't build itself. The work we've been describing today requires three things to come together. The first is connected data. Trade cost modeling falls apart when inputs are stale and scattered across several source systems and input files. A tool like Impact ECS can help pull together cost data from the ERP, procurement data, and other source systems into a single model. So when conditions change, we're working from numbers that reflect what's actually happening in the business rather than what was true the last update cycle. The second is the cost behavior logic. This is where the cascade effect we demonstrate lives. Impact lets us build the logic that determines how tariffs, landed costs, and sourcing changes flow throughout the full cost structure. Not just what costs are at a point in time, but how they respond when the conditions shift. That's what allows a single scenario input to ripple correctly through every affected BOM and finished good. The third is scenario capability. The what if question we've been asking all along this session. What if tariffs increase? What if we shift sourcing? What if volume changes? These are all native to how Impact works, and the infrastructure is built for iteration, not one-time analysis. Now, if any of this sounds relevant to the work you're doing and is of interest, I'm happy to carry on that conversation after today's session. That said, that puts us at about 38 on the clock with 5 to 7 minutes left in the session. I think now's a great time to jump into some Q&A. So please, if you have any questions, drop them into the chat. And, I think Stacy and Toby might help us read some of those questions off. And please also feel free after the fact to reach out to me. My contact information is provided on the screen. And if you have any questions that you're not brave enough to share with the group or something comes up later on, I'm always free to continue this conversation. So with that said, Stacy, do we have any good questions?
Yeah, for sure. I'll go ahead and hop in and throw one in as we're getting going. You talked a lot about creating models that take tariffs and other changes into consideration. But let's just say, for example, I'm a cost engineer in an environment that already has sort of a modeling scenario. You're talking about a lot of investment in changing how the models are built. Can you talk a little bit about maybe where we would start, right? If we were going through really trying to understand how we can incorporate tariff analysis and other things into our models?
Yeah, so the point is not to try to boil the ocean overnight, right? The starting point really should be based off of your particular business, your particular use case, your supplier network, the raw materials. If the focus is on implementing a tariff specific simulation capability, what you want to do is really focus by concentrating on your high impacts regions, suppliers in those regions, and high impact raw materials. We often find that if you look at sort of what you're purchasing, you certainly have, normally about a large concentration in, 10 to 15% of that raw material usage. So you'd want to start there, right? And then from there, build the capability out to start including other raw materials, maybe start including other suppliers or regions, and really start just sort of, I'll say, brick by brick, putting it together. Does that make sense and sort of get at the heart of your question, Stacy?
Yeah, I think so. Yeah. And I'll keep going. I'm going to say two things. I'm going to throw another question in, but as we're doing that, I'm going to launch a quick poll just so I can get some feedback from our attendees on what you thought about this session. But I'm going to throw this one in for you, Sam.
Okay.
Read it directly. How does your concept of a purpose-built dynamic model design differ from a traditional what-if scenario? I suppose this is the difference between proactive versus reactive modeling. But what are your thoughts around purpose-built dynamic modeling?
Yeah, so there's a couple things. One is certainly the point that was mentioned about proactive versus reactive, and that, something that's very much, I won't even limit it to tariff, but situational in design you can use it proactively much better and you can get through the iterations quicker. The other thing is just in a general what if environment, there tends to be more data that we're trying to manage at the same time, right? What you saw in my example was in managing the 5 fields or the 5 countries that we're sourcing raw materials from currently, I was able to immediately see the downstream effects. What you didn't see me was also have to manage my BOM master and my current raw material prices and my current supplier master and all those other elements. When I tend to think of a holistic model that has what if capabilities, it's the ability to edit every single input all at once and create a new unique blend of product cost and compare those. It's really useful in its own use case or specific use cases, but it also just makes the simulations much more cumbersome to run in practice, right? Whereas something that's very precision focused, like the tariff example that we walked through, you can iterate through them a lot quicker with this level of specificity.
I'm going to keep the poll open and I'm going to throw in one more question to you, Sam, and then we'll probably be getting close to time. We'll bring Jeff back in to bring us home.
Great.
But let's talk a little bit about data and granularity, right? Like it seems like you need to have a lot of detail in order to make something like this work. And you spoke a little bit to that in a previous question. Can you just talk a little bit about the level of granularity that you need to be able to do something useful, right, with
Yeah.
this?
Yeah, so in the example that we saw here today, we got pretty granular on the raw material side in terms of having identified the HTS code for every single material and things of that nature. And that's certainly not necessary, right? A lot of times you can start from simply just the supplier level of saying, where do these suppliers exist? Where are they shipping it from? And that's a much more manageable and reasonable starting point, right? If we have a supplier list and we can identify maybe 1 or 2 countries from there, you can then start to do things at a higher level. And to my point earlier, you'll start to see where where your risk is concentrated or your exposure is concentrated, and that might be where you want to start drilling in. So if you find the 10% of the raw materials, you can say, great, this is where we're going to start the mapping of the HTS. And that's just one example of the granularity, right? The other piece too is on the manufacturing side, for those of us that work for manufacturers, you can get really, really complex and granular in terms of how the raw materials ripple through the bombs, right? Think the complexity we can add if we have multiple plants in multiple countries. Within each one plant, we have multiple lines that they can run on. Within each line, we might have alternative bombs and routings because machine speeds and consumption rates and things of that nature aren't the same from one line to the next. And once again, it's, I would say, a matter of identifying where your high impact becomes. Does one plant in particular carry more exposure? That's the plant that we should start with and drill into. Does one particular finished good exist at 3 plants, but it carries a large concentration of the volume that we sell? Things like that can be sort of key indicators as to where to start your focus on where to get more granular, with the goal being over time to eventually have that ripple throughout every single one of your finished goods, all of your plants, all of your raw materials, things like that.
Excellent. Thank you so much, Sam, for helping us out. And I'm going to turn it over to Jeff for our final words. Jeff, if you want to.
Okay, thank you, Stacy. Thanks again, everyone, for joining us in today's webinar. I'd like to give a special thank you to our fantastic speaker, Sam Smith, along with Stacy Adams and the entire team at 3C Software for helping to make today's event possible. SPCEA continues to grow because of members like you, and we truly appreciate your support and involvement. SPCEA is your professional society, and we encourage you to stay engaged and help move the cost engineering profession forward. We're a nonprofit organization, and we're always looking for volunteers to write articles, develop training content, and to share real-world experiences with our community. For more information, please feel free to visit our website at spcea.org, sign up for a membership, and be sure to follow us on LinkedIn. And don't forget to save the date for the 2026 SPCEA Cost Engineering Global Conference. It'll be happening October 20th and 21st, and we hope to see you there. Have a great week, everybody.